So welcome to the fourth ever TensorFlow.js show and tell. We've got an amazing show for you today. And on the note of shows, I've put together a fun music video in honor of the Made with TFJS community to introduce this series. So without further ado, let's roll the video.
Yo, check this out. We're all up in the live streams, checking projects wilder than your greatest dreams. Join me for this community show, cause we're gonna make those one hot tensors flow. Come check out the new kid on the block. TensorFlow.js is gonna make your ML rock. You all have such creativity, so come along and you code with me. Now some people say that JS is just a toy, but I'm afraid you got it all wrong, boy. The time has come, I must confess, you all should be checking Made with TFJS. So get this party started and see what people made. Take your first steps, don't you be afraid. Come hang with us after the show. You know you want to make your ML skills grow. You can code in days, whatever you like. All the other devs have a longer hike. Deploy to the world with a web page. We'll amplify your reach and set a new stage. So that's all for now, come hang with me. I'm just a friendly DRE. Now the time has come for me to go. Please join me for the brand new show.
So on that merry note, let's get this party started. I hope you enjoyed the video. It was super fun to create, and around 90% of the video is actually created using real TensorFlow.js demos or effects, which just goes to show how many amazing projects are coming out there from the TensorFlow.js community. Now, a special shout out to our Google developer expert, Grant Laborde, who is featured in the middle of the video playing the machine learning trumpet, which is actually generated using Magenta's tone transfer model and is powered by TensorFlow.js running entirely in the web browser. It's super cool and worth checking out as you can convert your voice into an instrument of your choice. Check the link after the show in the description. Now then, as always, I know a lot of you have been looking forward to this next installment. It's great to see you all here and some familiar names in the chat. Hello to you all. We're back with even more amazing demos for your viewing pleasure. For those of you new to the show, I'm Jason Mays, developer advocate for TensorFlow.js here at Google, and I'm super excited to welcome you to our new home here on the TensorFlow YouTube channel. Please do subscribe and hit the like button to get notified of future events when we go live. Now, our audience today comes from a diverse set of backgrounds. Some of you might be new to TensorFlow.js, some might be new to machine learning, and some may be new to both, or others may even have a PhD in the subject. There's something for everyone, no matter what your background, but for those of you new to the world of machine learning, here's a very quick recap on what we're about to see. So TensorFlow.js is an open source machine learning library, just like the Python version some of you may have already been using, but in JavaScript. And what this means is that in a single click, you can perform machine learning in the web browser and beyond, essentially anywhere JavaScript can run, including server-side via Node.js, React Native for mobile apps, Electron for desktop native apps, and even Raspberry Pi via Node for Internet of Things. Now, if you're running in a web browser, you don't even need to set up any complex environment for others to try and model out. You can run on device, even offline, with lower latency as no server-side calls if you're using it in the web browser. And many of the models you know and love are being ported to run in this way to get even more eyes and minds exploring cutting-edge research for real-world use cases. So if you're a researcher tuning in right now, consider porting your model to the web as an easy way to get even more eyes on your amazing work and of course get feedback on your model too. And on the subject of amazing work, today we've got 6 demos built by folk from the TensorFlow.js community from all over the world, including Americas, Europe, and Asia. Now, many of the presenters today are live with us in the YouTube chat, so do feel free to ask questions as we go along. And of course, feel free to use those emoji to show some love. And a huge thank you to everyone who is presenting today in front of such a large audience. Now, links to demos and further reading will be in the description of a YouTube video after the show, so do check that out to learn more and to try things yourself. And to keep in line with tradition, for those of you who want to continue to nerd out after the show, we'll have a smaller Google Hangout at the end that's not broadcast live to meet fellow community members or to ask questions you may have about TensorFlow.js in a non-recorded setting. Maybe you've got a project idea and are looking for someone to hack with. Come join us afterwards to discuss. Okay, so with that, let's get the show started and meet our first presenter. So now we're heading to China to meet Shan, who some of you may remember from our first ever show and tell. And I'm excited to announce that Shan has some epic updates to the pose animator work she shared with us before. It's really great to see how an earlier prototype from the community goes on to mature into its own product. So Shan, over to you. Tell us more.
Hello, everyone. I'm Shen. I'm currently a creative technologist working at Google Partner Innovation Team. I'm based in Shanghai. So a couple of months ago, we open sourced this project called Pose Animator that allow you to use your body to animate your SVG characters. So people seem to like it, but we're thinking about how we might make it even better by making it easier for everyone to create animations. Because SVG, as it is, still requires quite a bit of design expertise to create. But we want to lower the bar even further so that anyone can create a character and animate them.
So that's amazing. So I guess now for the super fun part, can we get a demo?
Yeah, absolutely. So here we have Scribbly. It's very similar to Pose Animator. You can see the camera feed, and in the bottom, we provide a carousel of characters for you to choose from. So you can switch between a couple of presets. Our UX designer really loved this fun and playful design language. So
that is an amazing character. 10 out of 10 for creative drawing right there.
Thank you. So there are a couple of characters like this, and we also have a couple of AR characters. So by AR, we mean that we're simply showing the background camera feed like this.
That's cool.
So you can switch between a few presets like this.
I love how you can see how it's actually following the body here and you know, in real time adapting to whatever it is that you're doing. That's super nice.
If you want to create your own character, you can do so by clicking on this plus button. So we'll have a few body shape presets for you to choose from. So you can use those or draw one of your own. So I can do something like this. For example, this takes you to the doodle editor where you can actually doodle.
Mm-hmm.
And you can select your favorite color, change the stroke width, and I'm just gonna start doodling away. I apologize for my doodle skill.
Now we get to see your creative doodling skill.
Spoiler alert, it's not very good. Yeah, but I will try to draw a cat here.
Very nice. Yeah.
Give it.
I mean, we are on YouTube, so cats are the animal of choice. So good job.
Yeah. Yeah, you see, that's strategically planned. All right, here is a cat. So maybe I should give it a different color. All right, some whiskers of different color.
Beautiful.
There we go. Once I hit done, it will just kind of animate to my face. So like you can decide to turn the background off like this, and it will just show the plain background, or you can do it in AR mode, which is quite fun and actually introduces a little different use case because it really feels more like a full body AR filter instead of, you know, like...
Yeah, maybe you can show us the full body mode as well and just see it in action. Super cool.
Again, I apologize for my dancing skill as well. Yeah, but if you want to draw a little AR filter for yourself, you can really get quite creative with this. One thing I like to do when I create a filter is try to draw around my face instead of over my face. So like maybe let me create a new design from scratch. So this thing will be for AR. So I will just draw something in white. Give myself a little, I don't know, maybe a little hat, and yeah, I'll just do the hat this time. Yeah,
Beautiful.
and yeah, and it will just animate, and you can go back in, draw more, adjust however you want. And once you're happy with your design, you can do record. So you can record something up to 15 seconds in Scribbly. So I'll just do a little wiggle here. And once you're happy with the recording, we have a little trimmer for you to decide when to start and when to end. And once you can play it back to preview it as well. And once you're happy with the result, you can click save, and we have a couple of export options so that you can either save it as a GIF.
Which of course is very much required for social media these days. We love our GIFs on there, so good stuff.
Yeah, absolutely. So all the encoding for the GIF is happening in the browser, so nothing is leaving your machine.
Amazing.
This is pretty good. Yeah.
So one more question I have on this is that, is this still using the PoseNet and face mesh models only? There's a few new users watching this time from the TensorFlow channel, so they may not have seen this before, or have you added any extra ones?
You're exactly right that it's still using face mesh and PoseNet. So, like the same thing to detect the key points from your face and your full body. The only catch this time is we had to examine more closely the configuration we're running these two models with, just because we want to be able to support a good user experience on mobile and desktop as well. And the computing power on mobile and desktop is quite different. So we have to kind of use a more mobile-friendly, lower quality model on the mobile, and like the higher quality model on the desktop.
Yeah, so you can adapt to the circumstance that the user is executing in, which is super nice. And of course, like it's great to see how you've used it here to do both full body animations and also just the head as well. You can have just the hat if you want to. So it's very flexible in that respect, which is really nice. And you've got the multiple export options for GIFs and videos. So very shareable as well. So I'm very excited to see how creatives start to use this kind of thing to make short animations or whatever it is they might dream up. Super interested in that. So the other thing I'd like to ask at this point, of course, is if people watching want to try this out right now, is this live somewhere? Can they go check it out?
So they can check it out at scribbly.com. You can access it from both your phone or your laptop. So yeah, it should work on mobile. And
awesome. So we'll definitely put that in the description after the show. So do go check that out, people back home, and have a play of that. So awesome. Thank you for the demo. And I guess my only question left is what's next on the radar for this project? Do you have any future plans you can share, or how people can maybe get involved potentially?
So yeah, we're looking forward to open sourcing this project entirely. So it just takes some time to clean up the code, but we would love to open source it and get more people involved to build more new cool features. For example, like different export options. Maybe we can support importing a video into the product instead of like always recording live, because we thought it would be quite useful for for someone who's trying to create a short YouTube video and they have a recording sitting somewhere already and they might just want to turn it into a short animation to export, and audio obviously will be quite important for that. And yeah, at the same time, we're also very excited to experiment with the new TensorFlow models, such as the shiny new face mesh model, which apparently supports iris tracking now.
Yes, indeed. We just put out a new blog post on this one, actually. So yes, we now have the iris tracking, which gives you a lot more resolution around the eye. So when you're squinting or closing the eyelids, you can actually see that in all the surrounding points, which obviously for your characters might actually give a more expressive face or this kind of stuff. So I'd love to see that integrated into your product in the future. Definitely. That would be super interesting to see.
Definitely, definitely. It's also kind of like a challenge to see how well the algorithm can handle the movements around the eyes. Yeah, but we think it's super important in, like conveying expression and stuff like that. So yeah, we'll definitely revisit that and maybe even try out the hand pose model in the future.
Ooh, a third model in the mix. Actually, on that note, I'm
Yeah.
wondering, have you explored, like, if you're going to run so many models in the browser, are you exploring ways to run them in parallel? Do you have any advice on that from your current experiences?
Yeah, so it's definitely on our mind, and we're exploring different options. So one thing that we wanted to try out is like right now we can run two models simultaneously, mostly using WebGL backend. But there's a new backend coming out. Well, not exactly new, but like there's optimization coming out on TensorFlow.js side to support SIMD and multi-threading operations on WebAssembly. So that will mean it might work a lot better if we put one of the model on WebGL and potentially one of the model in WebAssembly, and maybe a third model, I don't know, on WebGL as well. But that's just something we're thinking about experimenting.
Yeah.
But yeah, what I've found personally to be really powerful is that because we're leaning on TensorFlow.js so much, we can really count on the infrastructure improvement on TensorFlow.js side without having to do much work ourselves. So that we're just really
It gets better with time, like a good wine. So yeah, that's excellent. And I think, yeah, as you said, the SIMD improvements are coming out, and then all the models will benefit from that once people start pushing to use WebAssembly for those models and so on and so forth. So yes, we'd love to see your experiments in the future to show us the performance differences and things maybe in some follow-up. So thank you so much for being on the show and tell today. It's great to see the updates you had for us, and look forward to seeing where it goes in the future.
Thank you, thank you, and I hope that you check out Scribbly. Just go there, do the round, make a few animation, and have fun with the product.
So thank you so much, Chan, for that creative demo and super fun opening to the show. What did everyone think? I'm personally very interested to see how the creative industry uses tools like this. Now, if you've got any questions for Shan, feel free to type in the live chat while she's actually here, or send some emojis to show your love. But now it's time for me to move on to our next presenter. So now we're off to Edinburgh to meet Chris, who's made a rather impressive Sudoku solver powered by TensorFlow.js combined with traditional computer vision techniques. So Chris, welcome to the show. And first off, tell us a bit more about yourself. What's your background?
Hey Jason, thanks for having me. So I actually studied image processing about 20 or so years ago, and I did a PhD in image processing. So that's my kind of background that kind of brought me here. And I was playing around with some image processing in the browser. I was building some self-organizing Christmas tree lights, and realized that it's actually quite straightforward to capture images from the camera and do some image processing. And it got me thinking about a mobile app I'd written quite a while back that was take a photo of a Sudoku puzzle and solve it on your phone. So TensorFlow.js, I realized that all the building blocks were in place now, and I could actually build an end-to-end system that would solve Sudoku puzzles in your browser. So I decided to give it a go and see what would happen.
That sounds awesome. So maybe we can go into a bit more detail on what you've actually created here.
Sure. Do you want to see a demo? I can show you it working.
That'd be great.
So I've got it running in the browser on my phone, and we can see it's scanning the puzzle and solving it as we scan over the images in the newspaper. So it works really well, and it's really fast.
Yeah, super fast, like pretty much instantaneous as you go over the grid there. Very cool. So what are the algorithms you're using to make this actually work then?
Sure. So there's some classic sort of image processing stuff going on. So we our main sort of bit before we actually feed into TensorFlow is to extract the actual image of the puzzle. So there's a few sort of standard sort of processing techniques we use for that, and basically there's a lot of throwing away of information. So we want to get to a thresholded image, so we just have a black and white image with pixels that are the printed pixels and pixels that are the background pixels, and then using that we can extract the actual digits from the puzzle image and feed them into an OCR system, and I used TensorFlow.js to actually do the OCR. So that was that was really interesting, and it worked sort of really well.
And on that note, actually, that's interesting to dive in a bit deeper there. Like, what did you decide to use machine learning for versus not? Like, what was your decision pattern there? Like, why did you use the ML for the digits, but maybe not for Sudoku grid itself or something like that?
Sure, yeah. So mainly, I kind of knew how to get to the point where I had the Sudoku grid extracted, and then the actual OCR bit was the bit that I wasn't really sure how to actually solve using classic techniques. So there's ways to do it, but they're not necessarily very accurate, and they're quite sort of old school now. And so the way to do sort of OCR nowadays is to use kind of neural networks and more sort of deep learning techniques. So I kind of knew that I had to use some kind of deep learning for the actual digit recognition. And TensorFlow seemed like the obvious choice, especially with TensorFlow Lite being TensorFlow.js being available. I could just run it on the browser.
Excellent. That sounds cool. So, did you use an off-the-shelf model? Did you create your own? What architecture did you use for the digit recognition?
Sure. So I rolled my own. I wanted quite a simple sort of model, so I could definitely run it on the browser without any performance problems. So I ended up with an input layer that's a convolutional layer, so a conv2D with 16 filters and a kernel size of 3. And then I fed that through a dropout layer to stop any overfitting. And then that goes into a fully connected layer. And then finally that goes into the output layer, which just has a softmax activation function with the 9 outputs, one for each digit.
Awesome. And is this something you invented yourself, or is this kind of from a blueprint somewhere? Did you have a background in ML before this?
I'd done a few courses on ML, so I'd done a few on sort of Udemy and Coursera. So I had a vague idea of what I should do, and then found quite a few examples on the internet of kind of simple sort of models for image recognition. So I sort of took some of those and repurposed them for what I needed, and then just tweaked the model and tried to make it as small as possible while still getting sort of good accuracy.
Perfect. So once you've got the network working, what was the accuracy of this?
Sure, yeah. So it was surprisingly accurate. So I ended up with sort of 99% accuracy on both the sort of training and the validation sets. So that was really pleasing. It was interesting. The images that it failed on were sort of 1s and 7s, particularly sort of where the font was quite sort of esoteric fonts or quite strange fonts with sort of italic 1s, sort of very bold, so they looked like 7s. There was one image of an 8 that was recognized as a 7, and when I looked at it, I could see that even I would kind of think it was a 7. So it was interesting to see where the neural network failed and where it was sort of confused. It was just like a sort of human would be confused. So that was quite pleasing, because I knew then that it was probably going to work quite well on lots of different characters.
Awesome. And what did you use to train the system with? Did you take lots of images of Sudoku puzzles, or how did you go around that?
Sure, yeah. So I did think about buying lots of newspapers and taking lots of photos, and then I realized that would take me quite a long time. So in the end, I downloaded about 100 fonts from Google, and then just generated small images with digits in them, and tried to sort of vary the sort of background and add a bit of noise to make it look like a printed sort of digit, and then just let that run for quite a while and just generated thousands of images to train on.
Very cool. Yeah, we're seeing a lot of this kind of data augmentation kind of being used these days, especially in the JavaScript community, which traditionally hasn't done so much of that kind of stuff. So it's great to see someone using this and getting great results with it as well. That's really cool to see.
Yeah, I was pleased that the sort of simulated data actually worked sort of well in the real world, because I know sometimes that can be an issue where you make up data but it's not realistic. So I was quite happy that it did seem to actually match what was sort of in the wild.
So it seems to be working super fast at solving the puzzles, but how is it actually happening?
Yeah, so once we've done the OCR, we've got the digits for the puzzle. So then it's a case of feeding it into a Sudoku solving algorithm. And I'm using something called dancing links, which is originally by a guy called Donald Knuth, who's pretty famous in computer science. And it's a really fast algorithm for solving Sudoku puzzles. So there's lots of information on the web on how this works, and it's really worth checking out, because it's quite a famous algorithm, and he's quite a famous guy. So definitely one to look at.
So it's really interesting to see like how you put all this together. And I'm curious like how you go about breaking down these problems in your mind.
Sure, yeah. So there are some sort of standard image processing techniques that you can apply. So I always try and break it into a sort of simple break it into a simple set of steps that you can sort of put together into a pipeline of image processing. So there's kind of thresholding, binarization, there's things for extracting sort of objects from an image. So it's quite, once you know those techniques, it's quite easy to build a pipeline that you can then stick together as a set of building blocks.
Yeah, and I love like how the machine learning is used here for a very specific purpose, but you've got all this other computer science going on that actually makes the program as a whole. And for those of you interested, Chris has made a really cool video that goes into much more depth of how he broke this particular problem down. So I do encourage you to check that out, and we'll put the link in the description as well. So if people want to try this out right now, is there a website they can go to do so?
Yeah, so they can. There's a site called sudoku.cmgresearch.com. I'll send that over to you, and that should work on any modern sort of phone, and it should just run in the browser. It will ask for permission to use your camera, and then you should be able to scan Sudoku puzzles. It does run on the desktop, but you obviously have to hold up newspapers to your webcam, which looks a bit silly. So.
Excellent. We'll put that in the description after this show, and do go check that out, people who are watching back at home. So looking to the future, is anything in the pipelines for this project progressing?
Sure, yes. I'm really interested in removing some of the classic image processing and replacing it with the neural network. So I do wonder if you can sort of push the neural network lower down in the stack. So get the neural network recognizing where the puzzle is, maybe even make it work end to end so it recognizes where the puzzle is and recognizes the digits all in one neural network. I think that would be really interesting to experiment with. I will have to work out how to simulate lots of Sudoku puzzles in printed newspapers, which I'm not quite sure how to do yet. Otherwise, it will be taking lots of photos, which sounds a lot of work once again.
That's super cool, though. I'm interested to see where that goes. Are there any other projects coming out?
Sure, yes. I've been playing around with a voice-controlled robot, and one of the limitations with it is that it's running on a microcontroller, so there's a limited vocabulary that it can respond to. So I'm quite interested in controlling it from the browser. And I think with TensorFlow.js, there's a few models for word recognition. And I think I can make quite a powerful sort of voice-controlled robot by doing that. So I'm quite excited by that next project.
That sounds awesome. So great work. Thank you so much for being on the show today, and look forward to seeing what you create in the future.
Thanks for having me. It's been really fun.
So that was some amazing work by Chris there, and I love how he broke down the problem into many parts to create the final solution. Now, often machine learning is just one part of the overall system, and this is a great example of that. If you're interested in more details of his process for this project, check out his YouTube video that I just posted in the live chat that goes into much more detail and will also be linked in the description after the show. And of course, do reach out to Chris in the live chat right now if you have any questions for him whilst we head on to the next demo. And on the subject of next demos, we have a very rare thing from the TensorFlow.js community, a piece of custom hardware specifically designed to work with TensorFlow.js so that it can be used in many different ways. In fact, it's about to be launched on a Kickstarter, so let's roll the teaser video he's created and then head over to our next presenter. So today I'm excited to announce we've got Paul from London over in the UK who's made something quite unique that we don't often see in the JavaScript community, some custom hardware powered by TensorFlow.js. Now personally, I love seeing JS devs tinkering with hardware, especially with the emerging web standards coming out for WebUSB, WebBLE, and so on and so forth. And I'd love to see more of this stuff coming out. So Paul, tell us more about who you are and what you've made.
Yes, hello, Jason. Thanks for having me on your show. And so we made well, I suppose you could call it a little robot. And its function is to follow a person and keep that person in the middle. So it's like your robotic camera man, or camera person, I should say, these days. But it's designed for a sports setting, particularly. My background's largely tennis and IT as well. I did a master's degree computer science and computer-aided product design long time ago. I didn't finish them, mind. But while I was on those courses, I developed a lot of interest and knowledge in sort of IT sector, and I kind of put that together with my sports background and trying to solve a problem largely in the tennis world, where recording people for video analysis is tough because there's not only usually obviously 2 people playing or 4 people playing, not usually a spare camera person. So it's for that function mainly, but it reaches, many crosscuts, many different sectors. So it's interesting to see where it can go.
Awesome. And what inspired you to kind of make this project in the first place? Like, what set you off on this journey?
Well, largely a little bit of intrigue.
Hey there, it seems we had a slight technical issue with the video we were just playing. We're going to try and fix that. But in the meantime, we're just going to go to the next video until we can rectify the video situation with the last one we're playing. So we're going to head over to our next presenter, and we'll see you again soon for Paul in just a moment. So today we're speaking with Samarth and Praveen from India to hear how they've used TensorFlow.js to create a system that can recreate digital face masks based on cultural events around their country. Hey guys, nice to see you today. So tell us more about yourselves and what you've made.
Hi, Jason. This is Samarth here. Thanks for having us. I work as a product designer here in India and come with a couple of years of experience at Adobe doing front-end development and bit of design for the AI machine learning division called Sensei. Lately, I've been doing freelance product design consultation and do a bit of creative coding on the side.
Hey everyone, I'm Praveen. I'm an interaction designer, and I also work as an independent consultant and a freelancer, as Samarth is saying. Although I have a very less experience of using any machine learning algorithms or even like a software or in code, so I am pretty novice at that level.
Cool, it's great to have you both here today. And tell us more about the creation you've made.
Yeah, so the project which we've done over here is created a 2D stencil or a template for traditional artists or digital artists to basically overlay on top of it so that they can directly import it into our tool to create an AR filter or a face filter. So we're using TensorFlow.js's face mesh model, which people can directly, as I said, upload an image and then use that as a 3D mask, or if they use the blend modes to create like a face paint.
Awesome, great stuff. Let's see it in action.
Hey everyone, so here you can see like a face mask which we use in our dance form called Chaw, and we try to use the TensorFlow model to recreate these on a digital platform where people could put them on their faces just like an AR mask. And then also we all thought that, okay, since we use these masks for traditional plays, why not create some sort of a space where people could record themselves playing with their masks and use them in their own social media content, since we are all locked down right now.
Awesome. Yeah, it's great to see a lot of variety there as well in all the face masks. And I guess people can contribute their own ones, or how does that process work?
Yeah, so for this project, what we did was we asked artists to send us their own creations and what they use in their own work. So it was like we gave them a template and they will paint their own masks or create their own versions of it, and then they could see it themselves, like how it looks on their face, and show it to people, and like share the fun.
Awesome. Very cool. And I assume this is using our face mesh model from TensorFlow.js to make this actually work. Maybe you can tell us a bit more about your kind of process in using that, because I know it's not a trivial thing to be able to take our 3D coordinates that face mesh provides and then convert it into a form that is usable with like WebGL and other things. So maybe you can talk about your process there and how you achieved that.
Yeah. So basically, when we first got the information around like the face mesh model is readily available, we saw the example on the GitHub page for the model itself. That was using 2D canvas. So I was exploring WebGL at that moment and figured that maybe the coordinates it's providing can directly be used as points. So WebGL provides different ways to render graphics, and the bare minimum one is points. So I started with that as a demo, and then once we were able to achieve that with vanilla WebGL, no requirement of any framework as such, we got a bit ambitious. And funny enough, when I saw that image, which was telling which coordinates are there for each face part on the GitHub page, it reminded me of UV maps. And then I was thinking like, maybe you can just use that as a UV texture map. What we stumbled upon was there was no mapping for what are the XY coordinates of the UV texture to the specific points. And that was the most arduous process for us to like build it all together, because we had to manually go on in like Inkscape and point out each XY coordinate of each of these. So we basically split it up among ourselves and tried to do like some trickery around mirroring them, because we know like the face is symmetric. And once we got that through, we were able to make like some triangle forms out, and then finally we put in like a full-fledged like texture in it. The caveat over there was because it was a UV unwrap, which was somewhat like a spherical in projection. If you draw a circle in like the 2D texture of it, it would come up somewhat like an oblong or like an oval shape. So what we really wanted to do was just upload any 2D illustration, because we were trying to make it for traditional artists who can possibly print that stencil out and rescan it back in. We actually came down to like went through Blender and figured there is something called front view projection for a UV texture unwrap. So I ran through like some high school math, figured all those things, and then came up with our own UV unwrap for this. And that basically allowed us to put any illustration, so that if I drew a circle like or glasses kind of a thing, it came out in the same shape on the face mask as well.
I see. And I am not an expert in this, so I'm guessing here what's going on there is that you've got the 3D mask in the 3D program, and you then got this 2D kind of texture, if you will, and kind of imagine shooting lasers through that image, and where they hit on the 3D model is the color that kind of part of the mesh becomes, essentially, right? But is that basically the technique used?
So basically what I did was I took the 3D shape in the research paper from the model itself, and then that had some mannequin-esque face, and I used that as a sample image, ran the face mesh model on it, and that gave me a prediction. Using that prediction, I placed the what is called like the laser right in front of the nose tip, and then just projected all those points back onto a 2D plane. So flattened out all the Z depth of it, and that gave me like a purely symmetric form of it.
Awesome. That's great that it works so well. I mean, it looks amazing. And it's a great way that you can now combine the 2D content with the 3D kind of mesh that you have available to run in the web browser. So really awesome. So where can people try this out for themselves? Is there a link for people to try this?
Yeah. So we've got like a couple of links. The project is hosted on GitHub itself. And then we also did like a workshop with Node School SF, where we walked through the process of building it. And that's also uploaded on YouTube, so we can share the link for that as well.
Awesome. Yeah, we'll put that in the description after the show. And of course, people do go check that out. Good stuff. So it's a super fun project. What are your plans for the future? Where is it heading?
Uh, so after finishing this much of code and this much of a prototype, we proposed this project to the Chandigarh Museum in India, where we asked artists to submit their face paint work, where initially when you do face paint, you actually paint your face, but instead here what they were doing was creating an AR face paint. So they submitted us their artworks based on the topic of biodiversity, and they were actually able to play with the tool and see themselves with the face paint as a virtual face paint. And after that, we are thinking to open this, have an open call for artists from all around the world, that they could submit their own cultural masks, and we could create a platform where they could like try it out on their face and share it with people. And other than that, there is another branch where we are trying to put it as a tool for other artists, like comedians in our country, to like have fun and create conversations among us.
Awesome. Yeah, I can imagine a really great like web-based editor to literally paint your own masks, maybe using 3D models in 3JS or something like this, and then you can export that and becomes part of this machine learning experience that you can then try on for anyone in the world, so to speak. So that'd be super fun. I look forward to seeing that. So have any words of wisdom you want to give our budding developers who want to make projects like this?
I don't know if it can call it words of wisdom, but I can definitely share some sources which have helped me in my journey. First of all, definitely is the Coding Train. It's an amazing, amazing YouTube channel where like there's a New York professor, Dan Schiffman, who does a lot of beginner-friendly videos on getting started in coding and creative coding and also machine learning.
Yes, totally cool. I'm a big fan of that channel myself, and I love how he, even when things go wrong, you get to see how he then fixes it and gets out of that situation. And he's done a lot of stuff with TensorFlow.js as well, so it's a great channel to go check out if anyone's interested.
Yeah. Apart from that, I think there is another YouTube channel called 2 Minute Papers, and they cover a lot of cutting edge technology bits around how people are applying machine learning specifically. And then lastly, I think there's a course called Fast at AI, which just covers the applicability of machine learning. It's not necessarily JavaScript if there are a lot of viewers who are looking for TensorFlow.js, but then in general, it covers a lot of breadth around what machine learning is capable of doing and how they can get started without going into the nitty-gritty arithmetic and calculus of it.
Yeah, definitely. That's always good to have like the high level understanding as well to appreciate what's going on behind the scenes. No matter what language you're using, it's still applicable to all of this stuff. So that's very cool. So thanks, guys, once again for being on the show today.
Thanks, Jason, for having us and giving us this amazing opportunity.
Thank you again to Praveen and Samar for that very creative piece. It's always good to see people using our models in ways that blend old and new cultural trends together. Now, again, if you've got any questions about what you just saw, do leave a message in the live chat. And a quick note, we are still working on Paul's videos, so we'll hopefully have that in not too long. So stay tuned for this. And onwards we go to our next presenter for now. So we're heading over to Shanghai today to meet Andreas, who's been hacking on some pretty impressive human-computer interaction demos for public smart displays such as photo booths, game controllers, and much more. So Andreas, great to have you on the show today. Tell us more about yourself and your background.
Yeah, morning, Jason. Yeah, I'm Andreas. I'm the technical director at MediaMan in Shanghai, and part of my job here is I'm researching new, interesting, and exciting technology that we potentially can use in interactive or experiential projects. And as part of this, we of course also came along TensorFlow.js, and we built a couple of pretty exciting things with that.
Awesome. Sounds like a really exciting job. Something I definitely like to get involved in the future for sure. Sounds really cool. So yes, you've got some projects that you've been working on. Maybe you can tell us more about what you've been hacking on with TensorFlow.js.
Yeah, so if you probably saw a couple of my demos that I already posted on Twitter, we have created a couple of gaming experiences, like a very simple kind of Flappy Bird game that you control with your head, with your nose. Another one is we have a car driving experience where you use a virtual steering wheel to guide a car. It's kind of an endless running experience to collect coins with a car. But there is also more full-featured applications like a photo experience where you use gestures and hand controls and even facial gestures to control this application.
That sounds super cool. Can we see them in action?
Yeah, sure. Let's probably start with the Flappy Bird demo here. And this Flappy Bird demo, Flappy Fun as we call it, while you see me appearing in front of the camera here, it asks you to raise the hand, so it detects I'm raising my hand. It gives you a quick introduction, asks you to give a thumbs up to start the game. And after that, it becomes like a funny workout doing the dance in front of the camera, where the bird is actually mapped to the position of my nose here, and it follows the position of my nose. This demo is done with TensorFlow.js using the PostNet model. And as I said, we're using the nose position to track the position of the bird. And yeah, I'll tell a little bit more about why we built this demo, but we can probably see another one. We can see this this car demo. So you see me here again in front of the camera, holding a virtual steering wheel, guiding this beautiful car through the city and collecting coins. And why did we actually build these demos here? Because in using TensorFlow.js, we used traditional TensorFlow before. Now we're using TensorFlow.js. We wanted to evaluate how well it actually performs and how well it performs on different devices. Because when you're building experiences that customers use, that they, for example, use by gestures or by motions or even by emotions with their face. A very important thing is it has to be responsive, and we wanted to know how responsive can we be with TensorFlow.js. And if you want to check out a technology, whether it's if there is lag or how responsive, how precise it is, a good way to start is always to create like gaming experiences, because as a gamer, you know, when you're playing a game and it lags behind, the controls lag behind, you immediately notice that when it becomes unplayable. So
it's definitely the ultimate test for sure. If you can play the game and control it and win, then you know you're doing well with your frames per second.
that's like the ultimate test. So this is why we started with this Flappy Bird experience. This was actually to check how precise can we be, because when you're using your nose to guide these birds through this maze of pipes, then obviously if it lags behind or it's just not precise enough, all that happens is you're ending up hitting the pipes. But as you can see in the demo, I was actually pretty smooth in navigating these pipes, and it's actually a really fun experience. The same thing goes for this car experience, where you're moving this car through the city. And if we had like a lag of 2 seconds every time we turn the wheel, then this would be completely unplayable. But as you can see from the video, it actually performs pretty well. So when I'm turning the wheel, there is just a couple of frames of lag behind that. And yeah, it's totally playable. It's really totally playable.
So I'd just like to dive into this one a little bit more, actually. So
Sure.
I think you said you're using PostNet to run this, and maybe a couple of other models as well in conjunction with this. So I'm kind of curious, like to get it running at this high frames per second, like what kind of hardware is driving this experience? Is it some high-end PC or is it middle of the range stuff? Can you give any more details on that?
Yeah, so in this for these experiences that we just saw, this is mostly PostNet being used, and PostNet is actually a very, very lightweight network. So the hardware we're using in this demo is like an i7 CPU, a pretty recent i7 CPU, plus an NVIDIA 2060, which is like by today's standards, is like a mid-range mid-range CPU. However, in order to run PostNet, you can actually use much lower-end GPUs too. I mean, this is the hardware I had available here, but especially for PostNet, we even have a demo running it on with TensorFlow.js, running it on mobile devices. It performs really, really well. Of course, we have a couple of other demos, like for example, this photo experience, which is a more full-featured experience and not just uses PostNet, but actually uses 3 to 4 networks at the same time.
Oh, cool. Maybe we can see that one now and just see that in action as well. Yeah.
Yeah, let's have a look. Let's have a look. Okay, let's go into the photo booth. So here you see another one of the demos here. This is like a photo booth experience where people can take a kind of holiday picture. So again, it starts by me raising the hand. I can read some instructions. I can use a hand gesture to activate it. Afterwards, I'm using again my hand to swipe around different backgrounds here. You can actually see I'm in front of these backgrounds, but not using a green screen or anything. I mean, you see the actual background is my workshop here, and we're using body picks to remove the background. And to start the photo experience, you see me first all grumpy here, like I'm not smiling at all. And I'm activating this photo experience by a smile. So it detects the facial expression. And after that, I have to do like the dance with different hand gestures. And then when 4 pictures are taken, I choose my favorite picture, again, using my hand movement here. And when I decide on a picture, I like grab it and pull it out. And again, confirm with a thumbs up. And then I get a QR code. I can scan this QR code with my phone and download it on my phone and share it on Instagram or whatever. So you can see there is actually not just one network, there is a lot of networks being used here. So actually, yes, sure, it's again PostNet, for example, to detect that a person is in front of the screen and that I'm raising my hand. But it also uses the hand post network to, let's say, detect the finger landmarks. Again, using PostNet to detect the swipes, using body picks for the background removal. So this is basically the virtual green screen that I have here. And there is another network called Face API, which detects like smiles or me being angry or maybe giving all kinds of facial expressions. So we're actually running up to 4 different networks here at the same time. And of course, this is a bit more taxing especially on the GPU side. So this is the only reason why I put a 2060 into this computer. If it's just for PostNet or just for a single network, you can run them on a mobile phone. I mean, this is totally possible.
Yeah, this is super cool. And I just like to point out here, we've seen a lot of the community exploring some HCI kind of stuff, like just with hands or just with the face or just with one thing. But I love how you've combined multiple things here to give a much richer experience that can do much, much more, in fact. And this is super cool to see that. I'm just curious, on the hardware side, have you explored at all kind of running on different parts of the hardware, different models? So maybe one model on the CPU, one model on the GPU, that kind of stuff, to see if that could help out? Or what explorations have you done there?
So what we've done here, probably we can have a look at the backend, actually, what's happening behind the scenes. And what's happening behind the scenes is we created a software which we call the controller software, which like controls and manages all the networks that are running and captures all the raw data from the different networks and combines them and also like filters them, cleans them a little bit. So you see here, this is you have several pictures here in this controller. You see the main camera image, which is, for example, me raising the hand. You see the PostNet landmarks, but you see also like hand pose tracking my hand, and you see Face API tracking my face here, especially because what's happening here is that 3 to 4 networks are running, and we package this into an Electron app here. And each of the networks uses its own process, which again then uses a WebGL backend. I mean, TensorFlow is usually WebGL based. TensorFlow.js is WebGL based. So each of them are using like a Chrome instance with WebGL to get the raw data. We're then using this controller software to first filter and clean the raw data, because as you know, this is like when you get raw data from a network, the data is kind of okay, but it needs a bit of filtering and a bit of let's say a bit of cleaning. This is what's happening in here. Also, what we discovered is that just using the raw data, it kind of works for some applications, but if you really want to push this to a production level application, then you also need to make some, how to say, for example, for PostNet, we do not use the direct screen coordinates of every landmark, but we're actually making them relative to the person's body, because people come in all shapes and sizes. And for example, to play Flappy Bird, a tall person would have an unfair advantage compared to a smaller person. So the trick is to make it all relative actually to your body. Like start with the shoulder level and then see how high can a person raise their hand, like about this level, or how low can they go, and always use the relative data to control this. So the challenge in making this wasn't just using the networks, but also how to use the actual data. You get to a certain point using the direct raw data of the networks, but you do have to do some cleaning and also some post-processing normalization, as we call it.
It's really great to see how you tackle that problem here to make it fair to all players, no matter what their body shape or size, and this kind of stuff. And I think people often forget it's not just a machine learning model. There's a lot of other work that goes around it to then make it a really playable experience and that kind of stuff. So it's really great to see you having done that there. So I guess my next question here is, what's the end game? Where is all this leading to? Is this going to be used in production, or what's going on here?
Well, this is absolutely going to production, because I really have to tell you, we're super impressed with what TensorFlow.js can do and how easy it is actually to use. And, it is going to production because there is a huge interest in applications that are being gesture-based or motion control-based right now, because, we still have COVID going on here. And it's not like in experiential or event business, people usually were used to touch things, like touch screens, touch physical items, touch physical elements. However, there is a huge trend now on converting everything to going touchless or gesture-based and something. So we do have, we actually offer touchless or gesture-based concepts in almost all the new projects that we do here. And clients here are very open to that. And we're doing projects on a regular basis that include touchless or gesture-based technologies. And yes, based on TensorFlow.js. So yes, this is absolutely going into production, and it's totally production ready.
I look forward to seeing it somewhere out in the wild next time I'm visiting China, for sure, and maybe elsewhere in the world too.
You're very welcome to come over. Yeah. Otherwise, just check out my Twitter. I'm occasionally posting a couple of cool projects there. So yeah.
Excellent. Awesome. So this is like really great stuff. And I'm sure the people watching right now would love to kind of try some of these demos out themselves. And I know some of these things are tied to the hardware of the kiosk itself, but maybe some of these are open source in some capacity. Do you have any links you could share with us?
Yes, absolutely. There is some things I already shared, like for example, a library which is built on top of hand pose, which can recognize like hand gestures, like for example a thumbs up or a victory sign. It's called Finger Pose, and it's available on my GitHub. There is a couple of other demos available on my GitHub, like for example for this facial emotion recognition. There are some demos how you can build gaming experiences around that. And yeah, we are eventually going to release this controller software that I showed you, which brings like all the networks together and filters and cleans the data. We are eventually going to release that also as open source, and I'm probably gonna put this on my GitHub sometime after Christmas. I'm using Christmas time to clean up the code a little bit, because honestly, it's still a bit messy and I'd feel a bit embarrassed to show this code to the world. But yeah, I'll take some time and put this on my GitHub, and I'll share the link with all of you.
Awesome. Yeah, so we'll definitely put the links in the description, of course, for everyone to click on. And do check those out after the show. And I've got to say, follow this guy on Twitter as well, because his posts are awesome over there. There's always something new coming out. So a very fun Twitter account to follow too. And with that, I just wanted to thank you so much for coming on the show today to talk about your experiences and demos, and hopefully see you soon.
Thank you for today.
Cheers. Amazing. So for those of you who joined the third show and tell, you may remember a member of the community exploring hand gesture to control interfaces. But I love here how Andreas has managed to combine multiple models for a production-ready experience at scale over in China. Now, of course, do reach out to Andreas if you have any questions. He's here in the live chat. And of course, we're going to now go back to Paul, as we've now fixed the demo, and over to Paul to see his demo in action. So today I'm excited to announce we've got Paul from London over in the UK, who's made something quite unique that we don't often see in the JavaScript community, some custom hardware powered by TensorFlow.js. Now, personally, I love seeing JS devs tinkering with hardware, especially with the emerging web standards coming out for WebUSB, WebBLE, and so on and so forth. And I'd love to see more of this stuff coming out. So Paul, tell us more about who you are and what you've made.
Yes, hello Jason. Thanks for having me on your show. And yeah, so we made well, I suppose you could call it a little robot. And its function is to follow a person and keep that person in the middle. So it's like your robotic camera man, or camera person, I should say these days. But it's designed for a sports setting particularly. My background's largely tennis and IT as well. I did a master's degree computer science and computer-aided product design long time ago. I didn't finish them, mind. But while I was on those courses, I developed a lot of interest and knowledge in sort of IT sector, and I kind of put that together with my sports background and trying to solve a problem largely in the tennis world, where recording people for video analysis is tough because there's not only usually obviously 2 people playing or 4 people playing, not usually a spare camera person. So it's for that function mainly, but it reaches, you know, many crosscuts, many different sectors. So it's interesting to see where it can go.
Awesome. And what inspired you to kind of make this project in the first place? Like what set you off on this journey?
Well, largely a little bit of intrigue as to whether it could work, because I've been using TFJS in a number of different capacities. The business behind this is a sports video analysis business, which is web browser based, and that we're using TensorFlow.js models on there, body pics, PoseNet, you know, for pose estimation and semantic segmentation. So we've got quite familiar with them anyway on a Cordova-based, browser-based app, and obviously on the web as well. So we wanted to try this out using the JS technology. We also built it in TensorFlow Lite with Flutter as well as a comparison, but largely that. And we've been really pleased with the early work. We've got a second prototype coming very soon. This is the original. And this new prototype's quicker, faster. It's got a few tweaks on the firmware, and it's all in all, it's going to be exciting to see where it can go. And where we're trying to get it is to try it in the hands of JS developers and people using it for its intended purposes.
Awesome. So essentially, it can capture, I guess, any sport play that you might want to do. Tennis is the use case here. And it will follow the person around the court as they're playing. That's basically the idea of this.
Yeah, so it's a robotic device. It's got a stepper motor inside, Bluetooth module. It's got an infrared sensor as well in case you want to use a manual control. So the way it works is that the robot itself, the firmware on the microcontroller connects with the Bluetooth on the app. So we just hacked up a Bluetooth GitHub for Bluetooth plugin on we're using Cordova as the kind of web browser based app that uses the JS, and so we've kind of connected via the Bluetooth. So that syncs obviously the phone, the device, and obviously the robot together. And then with our app software that we've coded, we ping signals to the microcontroller on the firmware, and those signals will just a string, basically, kind of integers and characters, and it'll say like CW clockwise, 25 degrees, speed 1, 2, or 3. I mean, the latest prototypes, unfortunately not here right now, that they've got 7 speeds and a better firmware, so we're hopeful that we can even improve quite a bit on that. But so with that string, it will then move the device to keep the person in the middle. So it's always going to keep the person in the middle, and then as soon as that's done, it will move on to the next command.
Awesome. So before we dive deeper into the technology here, maybe we can see a live demo of you demonstrating this.
Yeah, so okay, I'll turn this around. We're looking at you at the moment, Jason, but okay, I'll turn this around so yeah, you can see that there.
We can see that.
I'll move this out of the way. And so if I move back a bit, and then this should just follow
Yeah,
me there.
it's turning around as you walk around the room.
Yeah, so I can probably walk out the door even, and it's following me around. In the latest version that we're just about to hopefully release with the new firmware on the new prototype, it'll be much, much quicker. There was an oversight. We didn't include in the firmware an interrupt stop signal. So it means that when we pass a signal, the string, it's got to complete that before it receives the next signal of the location of the mobile net image classification model that is sending where the person is. So with the new version, it'll simply, as soon as the person goes out the middle third, it'll just use a command of move left or move right, and then it will stop at the point it comes back in.
So if it's mid kind of moving, it can kind of pause faster and start going in the correct direction.
Yeah, it just means right now there's a little bit of lag, but we've addressed that in the latest version. And yeah, if you keep following us, I don't know, on some our social media, you'll see the latest versions. And say not ready for this presentation, but you'll see it at some point.
Cool. So diving into the tech stack a little more then. So you're using TensorFlow.js and is it our pre-made models, or did you kind of customize one of our models with your own data?
Yeah, no, it's basically just an out-of-the-box mobile net V2. And yeah, we actually coded two apps. We coded TensorFlow Lite with a Flutter base. We just wanted to do some comparisons, either like performance or the UI. And then we've got a Cordova-based platform that we're kind of obviously a sort of wrapper app, browser-based wrapper app, where we've just got JS plugins in that. And yeah, it's just a straight out the box TensorFlow model. And yeah, the mobile net V2 is really lightweight. That was the key thing, because we wanted to maybe use sort of probably PoseNet, something like that, because I think it'd look nicer to have like the skeleton following, but it was such a good lightweight model, the mobile net image classification model. And also it presented the option as well, if a further point we wanted to adjust the app to maybe follow a dog or a cat, or just, it gave us more flexibility to maybe follow other things in the code at some other time.
That's awesome. So easy to upgrade these things too. And of course your use case here is sports, but even like security cameras for the home, like the fact that you just monitor you going around your room right now, that's really cool too. So there's many applications you could like maybe spin it off as well in other ways, which is kind of cool.
Yeah, absolutely. Yeah, it's the use cases are tremendous. I mean, just I was watching one of your TensorFlow previous show and tell videos, and some of the incredible things the other community members are doing, and I'm kind of watching those thinking, let me just say, I was watching one from a guy called Gant Laborde, and he got this kind of presentation. He was doing presentations and was able to test the mood of his audience.
Yes.
And I thought, what a fantastic project that was. And then I suddenly thought, wow, if Gant had this device, programmed it into his kind of presentation so that he's moving, the device is moving around, keeping Gant in the middle, while
right, that's true. Yeah, it could be even like cooking.
Then he's going to get more smiley faces.
Kitchen.
He's going to get more smiley faces, and so yeah, the use cases crossing over to different projects. It's quite exciting, really.
So I'm also curious about any challenges you faced whilst making this project and how you overcome them, as this is quite a unique project.
Yeah, probably the initial challenge was trying to match up what the camera field of view sees compared to the obviously the model itself. So we tried to originally we tried trigonometry to work out the angles and everything in the field of view of each smartphone, because obviously they're all going to be different. That produced some funny results. I don't know whether it was our coding or whether I think trigonometry is a pretty accurate form of measuring angles, though, so it must have been us. But in the end, we decided on we actually wrote a function to return the pixel count of the device and its configuration, and then with that total pixel count and its configuration, we then split the screen into three sections, obviously thirds. And then the middle third, we said basically if the mobile net model is in the middle third, then stay where you are. If it enters the left or the right, then we'll ping a signal of how many degrees it needs to travel and how quickly in order to get that person back in the middle. So that was quite a challenge that we got there with that.
So I guess from what you said there, I'm guessing by having it splitting into thirds, it only ever moves when things actually start going off to a certain direction. Whereas before, I guess it was maybe just too precise. It was just kind of updating all the time, leading to a lot of movement or something.
Yeah, it could be. I mean, our new prototype coming will have a firmware amendment that will basically have an interrupt signal. So we don't need to be processing strings, integer and character strings that is in a code that we fire to the robot that basically will turn it so many degrees to the left or the right. The new one will have an interrupt signal where we can say stop. So it'll basically simply say, are you in the middle section? Great. If you're not, then move ongoing. So it'll be nice and smooth, and then it will stop when it comes back in the middle section. So that's something we're looking forward to coding into the next prototypes that'll be here any day.
Cool. So I know this is a hardware demo, but is there a website that people watching right now could learn more about this project if they want to find out more?
Yeah, the website is ava.website. That's the website where you can find a little bit more about it. There's the social media tags of Ava videoing on Twitter, and there's a Facebook page for Ava. It's called Ava. We called it Ava because we called it the automated videoing assistant. So search for automated videoing assistant, Facebook, Twitter, and you'll find us. And we're also trying to get this off the ground on a Kickstarter campaign, because right now we've just got a bunch of prototypes, and we want to try and get this out to the TensorFlow community and wider afield, and let everybody program their own things on it. But in order to do that, we need to try and get a minimum order from China. So we're doing a Kickstarter as well. So have a look for the details on that too.
Awesome. We'll put the links in the description after the show. And of course, as you're one of the very handful of people who've experimented with hardware creation, I'd love to hear any of your advice for people watching if they would like to get into this kind of space too, to make custom hardware that uses TensorFlow.js to power it, or even just TensorFlow even. Any words of wisdom you've learned from this experience?
Yeah, definitely. I think the first thing you need, and we've learned it firsthand by having this first round of prototypes missing a key simple thing like an interrupt command, a stop command, and then suddenly we're having to... So really plan out your project and what you really want it to do really well in the beginning. And then you want to try and work with a development board. So you can probably see here, I've got some... So this here, for example, is a development board. It's ESP32 module. You could get Arduino, Raspberry, any of these kind of development boards where you can buy modules and attach them to it, change the jumpers, code in your firmware. So essentially you get a perfect development environment. And then once you've got the development environment doing what you want, think about your casing. You can get that printed on a 3D printer, for example. And then when you've got your casing and you've got your development environment, you can then create a thing called a Gerber file, which is basically what would be required for a printed circuit board. And then you can get that manufactured in China, get a prototype, and then try and get it out and about, which is the point where we are right now, trying to hopefully get a lot of people wanting to buy these, whether that be for fun development in the JS community, or whether it's people actually wanting to use it for various intended purposes, like recording tennis players.
I see there's some other hardware on the table there. What is that? I see something on the table.
So this here is very much really early stages. So this has got like a cam here, and we can screw this on to this device and then screw the attachment onto that. And then this will be loaded on with TensorFlow Lite onto the microcontroller. And then we can connect that to the device instead of the smartphone to the device. And that will take care of the, obviously that will now recognize, hopefully, the person in the view, which will mean it frees up the phone, or you can mount anything on it, a GoPro, or so it completely frees up the phone, so you could load up Facebook Live or whatever.
Nice. Yeah.
Google Meet.
Cool. So all on device essentially, and then you can use the phone for its other purposes. Awesome. So thanks so much for coming on the show today, and I'm excited to see where this project goes.
Thank you, Jason. It's been fun. Thank you.
Again, great work, Paul, and best of luck in your launch. You can find more details about the project in the description, and I'm super excited to see more hardware experiments with TensorFlow.js in the future, as JS can run pretty much anywhere. Now, if you make something awesome using TensorFlow.js, remember to use the Made with TFJS hashtag on social media so we can find your work. This is basically how we find all of our future presenters, so get hacking. Now, do reach out to Paul in the live chat if you have any questions, and we're going to head on to our next presenter. So here with me now, we've got Emily joining us from New York, who's managed to bring paintings to life using a combination of TensorFlow.js and TensorFlow Core. Now, this marriage of technologies across the stack is a super fun use case and something I'd love to see more of coming out of both the Python and the JS communities. So Emily, what did you make? And tell us more about yourself.
Sure. So my name is Emily. I am a software engineer, and I recently made a fun project that riffs on this urban legend in which if you stand in front of the Mona Lisa, her eyes will follow you around. So this is known as the Mona Lisa effect. And obviously this doesn't actually happen in real life. And so this digital portrait that I've made does just that. So it's deployed at monalisaeffect.com. And if you pull that up and then turn on your webcam, then Mona Lisa's eyes will follow you around.
That's super cool. I love that you've chosen to bring that to life. That's definitely a fun one to do. I'm curious to know, like, what made you desire to do this in the first place? What was your inspiration here?
Yeah, that's a great question. So I'm not sure if there was like a particular thing or moment that gave rise to this project. Not that I can remember distinctly, but I suppose, this is probably born out of my multidisciplinary background and interests. I love art, but I also program professionally. And I suppose I'm just the type of person that gets a lot of like random, unrelated thoughts at the same time. And so I think when ideas collide, they just come out of nowhere. But I've also noticed that in a lot of machine learning projects, they do sort of use Mona Lisa as an example. And so this kind of just pushed it to a new level, right? Yeah.
Very cool. So yeah, this is a super fun project, and clearly there's like loads of creative potential going on here. And I personally would love to see something like this in an art gallery with those new modern TVs that can look like paintings. And then of course, it can actually come to life as someone is in the gallery unexpectedly, which would be super, super cool. So let's head over to the website and see it in action. Okay, so here we are on the web page, and hopefully I've enabled my webcam. And as I move to the right, you can see her face moving to the right there. And as I go to the left, she does indeed follow me to the left. That's super cool. I love this effect. And it seems to be working really well. So can you tell us more about how this is actually created? Like what models is it using behind the scenes and how it's all stitched together?
Sure. So I would say that at a high level, this project pretty much involves two basic things, right? The first of which is just generating a series of frames of Mona Lisa's head with her eyes sort of moving from left to right, and of course a little bit of a head turn.
And this is on the Python side, right? This is the Python layer that we're speaking about.
Yeah. The side did all using the first order motion model, which I'll explain a little bit later, and did it in Python. And then the second part was all in JavaScript, and this was using TensorFlow.js. And that was just trying to figure out which of these frames to render based on the viewer's location. And that's all detected through the webcam piped through TensorFlow.js. So.
Awesome. And I believe for that second one there, you're using our face mesh model to do the where your face is positioned in the camera frame. Is that correct?
Yeah, I'm using BlazeFace.
BlazeFace.
But yeah, so for the first part, I used a deep learning-based image animation model known as the first order motion model, as I mentioned. And for this, what you really need is like a driving video, which will dictate the image that you want to animate. So I selected this mostly just for its ease of use, right? The author of this model, Alexander Sierra-Honen, I hope I did not butcher his name, but he provided an out-of-the-box set of weights that you could just apply. And so for me, this really meant that I could, clone this repo into a collab notebook from there, it was a matter of like doing all the work to produce a video of me with my eyes moving from left to right. And then of course, like in that notebook, just taking a screenshot of Mona Lisa's head and that video and feeding it into the model. And then of course, producing the results.
So essentially it's taking the frames of the video that you produced, understanding your facial position in that time, and then trying to re-render the Mona Lisa's static face in different perspectives based on its best guesses of what that would look like, I guess, of its knowledge of human faces and so on and so forth.
Exactly. I think the challenge here, the interesting part was that, you know, I wanted to work within the constraints of this first order motion model, the constraints of this set of weights that the author provided, just specifically so that I could avoid having to retrain the whole thing, because that would take a lot of time, that would take a lot of resources. So yeah, working within these constraints meant that I had to use a 256 by 256 image as well as a driving video. And it also produced like a lower resolution than I would have liked, because I guess if you do 256, it meant a lower resolution image of the Mona Lisa's head, right? But I wanted to display not just the head, but the entire painting. So my workaround here was just to sort of take these frames and superimpose them on top of a high resolution image of the painting. But the problem with that was that it was just very obvious that it was a picture on top of another picture. So I did a lot of work around that and trying to figure out how do I get around this issue. The way I did this was by gradually sort of blending for the head frame, gradually sort of blending it, blending the underlying image into it. And I did that just using a function that I guess at the end of the day looks like kind of like a mirrored 2D sigmoid with values squashed from 0 to 1. And those values would indicate the percentage of opacity of the underlying image that would be taken in.
And yeah, having seen this in action, it works surprisingly well, actually. I've seen this being overlaid, and you know, the human eye doesn't really tell that it's actually a lower quality version of that image. I'm guessing because of the persistence of vision or something like this. As the frames blend, it's a moving image rather than a static one. Eyes are tricked by this kind of effect, and it looks much higher res than it actually is. So that's super cool. So you got the images from stage 1 from Python. You got all the frames generated. So what's the second step of this process? How did you then get it all working in the web browser with TFJS?
Sure. So what I ended up doing was using TensorFlow. I knew that I wanted to feed basically webcam input to one of the models, right? Because we'd use a webcam to track where the user was. And based on that, we would pick a corresponding frame, right? If the viewer was to the left of the webcam, we would want to display, you know, a Mona Lisa with her eyes more to the left, right? So I decided to use Blazeface, and yeah, there were a number of models that I could have selected, right?
Yeah, exactly. We've got a few like body detection things and face detection out there. So yeah, for those of you listening, we've got essentially face mesh, PoseNet, and BodyPix as well, which can all technically track the body around. But you went for Blazeface. Maybe you can tell us like why you chose Blazeface over the other ones.
Yeah, absolutely. So I actually ended up playing with some of the models that you mentioned, specifically, I believe this is BodyPix and PoseNet, I think the two of them, right? And they actually proved just a little too hardcore. They were kind of like computationally intensive, and I needed this animation to be convincing. And in order to do that, it needed to be pretty instantaneous, right? Like if you moved slightly left, Mona Lisa's eyes would need to also move like in real time along with you. And so Blazeface was awesome because it was it's super lightweight, right? Like it's fast. It's fast and lightweight, and that's why I picked it. And additionally, it was also built for mobile in a way, right? And mobile input actually very much represents the input that I would be expecting for this project. Like I would expect that a viewer is in front of their like laptop webcam and potentially on mobile and sort of front facing with their head forward. And I didn't expect that their head would be out of the frame. I expected them to be,
Sure.
right.
It's probably unlikely they're standing up as well, having a full body situation. So yeah, you want to check the general face region to see where they are in the
Exactly.
frame. Yeah, that makes sense.
Yeah, exactly.
Awesome. So I'm just curious, will you be replicating this effect on other paintings for people? And if not, is it easy for someone to take your code and maybe use it on other paintings if they wanted to do so?
Yeah, so I've definitely thought about like other fun applications of this. The feedback that I've heard from people is, Harry Potter, there's moving paintings, moving images, right? So I thought that would be kind of fun, but not quite sure about what the like copyright issues are there. So maybe not. But if other people wanted to, replicate this on, images in the public domain, you can certainly go to my GitHub profile, and you can see my see all the code for it, and you can start playing around using that as a starting point.
Awesome, very cool. And of course, if the Harry Potter folk are watching, get in touch with Emily if you want to use it. So good stuff. And on that note, actually, Emily's written a really amazing blog post article over on the TensorFlow blog. So if you'd like to go in a little bit more deeper detail, do check that out after the show as well. So thank you very much, Emily, for being on the show today, and we look forward to seeing what you create in the future.
Well, thanks so much for having me.
So thanks again to Emily. I particularly love how she's combined the strengths of TensorFlow Python and JavaScript to produce this. And I hope we see more hybrid approaches like this in the future, combining our communities together. Now, if you've got questions for Emily, feel free to reach out to her in the live chat right now. I see she's in there. And with that, thank you everyone, and to our amazing presenters. Feel free to share the recording with your friends or colleagues who could not make it here today live. And a reminder that all the links to all the demos will be in the description very shortly. And a reminder to use the Made with TFJS hashtag over on Twitter and LinkedIn if you make something cool to have a chance to be featured here in the future. Thank you again for everyone tuning in today. I hope you're as excited as I am for the future of machine learning in JavaScript. And I'll be seeing you all in 2021 with even more great demos. So look out for the next show. And now it's time for our private hangout for those of you who wish to join a non-recorded setting to meet fellow community members and maybe even presenters if they're still about. Feel free to join using the link that I'm about to put in the live chat. And thank you again for watching, and see you next time.